Okay, well, this is Aaron Murakami. Today is March 27, 2016. Guess happy Easter if you celebrate Easter. We did have quite a few people log on about an hour ago, but they were thinking it's Pacific Standard Time instead of Pacific Daylight Savings Time. But in any case, it's 11:05 where I am, and you can hear me okay, Eric?
Yeah.
Okay, so right now we're about 3.5 months out from the conference. If you're going to be coming to the conference, there's not many seats left. Most of the seats have already been paid for, but you can find the information on EnergyScienceConference.com, and that's going to be on July 8, 9, and 10, which in Hayden, Idaho, which is about an hour from the Spokane airport, and that's the first weekend right after 4th of July. We'll have about a dozen speakers there, and Eric will be presenting. It'll probably wind up being another 4-hour presentation. And in case you don't have Eric's website, it's Eric P. Paul, P stands for Paul, so ericpdollar.com. And if you want to support EPD Labs, it is a 501c3 nonprofit organization in Nevada. And in the right column of that website, you can find information on how to donate by PayPal. And there's an address if you want to send any kind of checks or money orders to help out the organization. Do you want to just start going into the, well, actually, I do have one question that somebody submitted at Energetic Forum. I believe it was David Dawson. Let me start with this question, and then we'll go into, you can kind of cover the presentation that you're going to be doing, and then we'll open up for questions. So David's question is, what would be the best application for your 2C22 regenerative magnifying receiver to be used for? And he attached a picture, but you can't see the picture. And he's asking if that was intended as a receiver for the Crystal Radio Initiative, and how was it to be applied, and over what distance as an example, and what was the input required, or was it just a telluric radio station signal that was to be detected and received?
Well, it's best to start in the AM broadcast band with that, but he might not have an AM broadcast band where he's at. That stuff's starting to disappear. So that was something that I wrote up a long time ago. It was an attempt to combine the Armstrong regenerative detector with the Tesla transformer. It might be a lot more difficult than it seems, but I think the basic circuits will work, but the tuning could be difficult. So it's going to be, whoever will be doing this, it's going to be some frontline experimentation.
Okay. All right. Well, hopefully that'll answer it for David.
Well, he can always write me, and I can get into more detail. It's easier, exchanging that way and writing stuff down than talking about things on the phone. Open loop.
Right. Okay. Let's see. You want to just go into your what your presentation is going to be about? Here, I'll go ahead and let me pull your bio up here real quick on that. Energy.
Yeah, it's kind of like the beginning of all these presentations. It has my head reeling with the work involved in it. So these things are usually about 3 or 4 months of intensive labor. So in this case, I suppose a good popular name for the presentation could be called Through the Looking Glass. The whole idea is to get out of the electromagnetic concept and into the magnetodielectric concept and define propagation in that set of dimensions. So that's why initially I titled it Wave Propagation in Multiple Coordinate Systems. And then at the end, I will probably try to specifically apply it to the Tesla transformer and the Alexander's antenna, like I did in the extraluminal one. So this basically is a continuation of the extraluminal presentation. So I'm trying to figure out how to take the infinite complexities of network theory and reduce them into something that can be readily understood. This really cannot be considered a lecture for the layman, but it's not going to be overly complicated either. So, and then I'm going to try to concentrate on specific circuits. There's something that I think has been seen on the video already of me working on these networks on the bench. Those networks will be analyzed and described in the presentation. And the whole concept of propagating through counter space should be fully developed into something that can start to seem engineerable. So it's early to tell yet, but usually about June everything all falls together, and I know exactly how I'm going to deal with the situation. So right now it's kind of just a sea of equations and piles of books by Bell Telephone scientists, and it's really working me over. But at any rate, that's where that's at.
So the network videos that you're talking about, early December, before I went down to this business meeting in Henderson, I took some film of you doing some of those experiments on the bench. And if anybody wants to see those videos, that's on youtube.com/Aaron Murakami. That's my YouTube account. You can see within the last 10 videos or so, there's one where Eric is giving a walkthrough of those that analog network on the bench, and which is similar to the experiment, those longitudinal transverse experiments he did in the old Borderland videos. And another way you can find it is if you go to ericpdollar.com and you just scroll down to, within the last 5 or 6 posts on that site, the video should be embedded there too. And also if you go to energyscienceconference.com, and if you just mouse over speakers and talks in the menu, you're going to see it pop up with 2012 through 2016 speakers. Just click on 2016 speakers, and you can see Eric's description there of his presentation that he'll be giving, which is, I think we're calling it Electrical Transmission in Multiple Coordinate Systems. Are you still going with that title, Eric?
Yeah, that's kind of the technical title, and then the popular title will be Through the Looking Glass, because that's basically what's going on here, is going from a coordinate system that's generally understood into a coordinate system that is virtually not understood at all. So another way to look at this presentation would be that it's going to be a basic course in the development, design, and construction of what are called artificial electric lines or analog computers. So I've produced a couple of video presentations on this. One was for an amateur radio club in Santa Barbara, which might be a good introduction or prelude to watch, so that whoever is going to be at the presentation will have a better idea what's going on. So the framework of the book, or the presentation, and actually it's going to be the second volume of my transmission book, part of it, is Arthur Kennelly, the chief electrical engineer for Thomas Edison, and a collaborator with Steinmetz in the development of the Heaviside approach to electrical engineering, wrote 2 very important books. One of them was The Application of Hyperbolic Analysis to Electrical Engineering Problems, and the other one's called Artificial Electric Lines. And basically the presentation is going to be directly based on those 2 books, but extended and worked out better, because these books are filled with conceptual flaws and typo errors and little regard for the beginner. It seems like it'd be easy when you start them, because they talk in easy-to-understand terms, but then things get all screwed up. And the Artificial Electric Lines book, all of the copies have whiteout streaks all through all the equations, so it requires somebody that's really an expert in this subject to weed through that, and then you have to have all the associated reference books. So there's one book by a Bell System scientist named K.S. Johnson called Transmission Networks. That is an important part of this presentation. Another one is also by a Bell System scientist named Shea, S-H-E-A, again on transmission networks. And those are basically finalized in a book by Ernst Gilliman entitled Communications Networks Volume 2. So this basically is the soup that the presentation is going to be made out of, roughly 4,000 or 5,000 equations. Fortunately, I only need about 10 or 20% of them. And then I get to take it to the next level that the great minds finally gave up with.
Okay. You want to go ahead and just open up for questions?
Yeah.
Okay. Does anybody have a question? There's only a handful of people on the call because most people logged on at the wrong time. But
I have a couple questions for Eric, but I can step back.
Go for it.
Okay. First, I was watching a YouTube video of yours a little while ago, and you mentioned in it that the sun is not a globe, but rather a disk, more of a transformer than something that is generating some kind of nuclear energy. You recall that? Now, I don't have an argument with it. I'm asking the question because I'm curious about that. It's very fascinating, the whole idea of a flat sun.
Well, no, somehow that got misinterpreted. So I've never said that the sun was flat, but I did say it was hollow.
Hollow, okay.
And what goes on inside the sun is unknowable to human beings.
Gotcha.
So anybody's theories are next to worthless. And then when you study this stuff, like I did at Sonoma State, and you start to get really deep into the literature on the subject and the examinations of all the photographs and diagrams and what have you, as the sun, as it goes through its daily dynamic routines, is that the whole nuclear fusion concept is really not what's going on. The nuclear fusion just occurs in the discharges that occurs between the sunspot pairs. The sunspots always occur in pairs because they're the surface spreading away from the outer surface of the sun, kind of like they call them solar cyclones. So the sunspots are openings into the inside of the sun. And then this loop, this magnetic loop, comes out from one sunspot and goes into the other, and the current densities and temperatures in that loop reach a such point that that's where the fusion reactions occur, and that's what broadcasts the microwave to X-ray band spectra that emit from the sun during these solar flares. The actual source of energy would have to be a transformation process within the sun, where you could say energy is being taken from one coordinate system and being delivered to another coordinate system, like a transformer.
Yeah, that's amazing. It really does, though, fly in the face of, I don't even know if fly in the face, but runs total contradictory to guys like, and I'm not a big fan of Neil deGrasse Tyson, the other astrophysicist, difference between the way electrical engineers and astrophysicists see things. That's why I wanted to talk to you. Yeah, the question was, excuse me, there's been some experiments I've seen online, and I've noticed it myself to be true, that, we've always been told that the moon is emitting light because it reflects light radiation from the sun, right? And it reflects it back down to us. But there's an issue with that, or at least something we don't understand about that. When I stand in the sunlight, I'm warm. If I move over into the shade, I'm cooler. And the ground is hotter in the direct sunlight, and the ground is cooler in the shade of the sunlight. Yet at night, if I stand in direct moonlight, I feel cool. And if I stand in the shade, I feel warmer. And if you measure the air temperature or the surface temperature that's been exposed to this light, whether it be direct moonlight or the shade in the moon, the air in the ground in direct moonlight is colder than the shade of the moon and the surfaces that have been affected by the moon. So how can it possibly be a reflection of the sun's light? Have you heard anything about this? Do you have any ideas? Or it's really amazing.
No, I haven't. The temperature the conjugate temperature thing I never heard of, but that's interesting. But then on the basis that it has been said by people that were out there to experience it that you cannot see the sun or the stars in outer space, in that there is no direct light, which then means there would be no propagation constant between distant galaxies and the Earth, and the whole thing of it taking 50 million years for the light to get here might be bogus. So what apparently is determined out of this is you can see the moon, you can see the Earth, you can see the reflection on physical objects, but you can't see the light from the sun, so that means that it's not a reflection. That means it's a transformation process where the primary emission from the sun, which is in dimensions and coordinates that we don't really know about, when it interacts with matter, then the so-called electromagnetic light is produced. So during the day, the sun would be using the Earth's atmosphere to generate the electromagnetism, but at night it would be using the moon to generate the electromagnetism, which then has to propagate here, and then whatever other electric charges and currents and whatever flying around through space, that stuff is really, no one wants to talk about that, so you can't get a lot of information on it, but overall it's a quite complex system. So it's quite possible that this primary transmission before it becomes light from the sun and the stars has no propagation velocity, and that the Einsteinian theory of it takes so many light years for the light to get here could be completely false. This is a consequence of the transmission theories that I've been working on also, to apply transmission theory in general to transmission systems that are not utilized in any way today, like those of Tesla and Alexanderson.
Well, that is amazing. I got to tell you, I love listening to your stuff and hearing your comments. It's like the reality we've been told doesn't even exist. Things actually exist in a whole completely different way. You can't see the sun, but yet it's generating energy. It almost makes me wonder if the thing is even out there, if it just exists in a completely different way. I don't know. I mean, obviously you could just you could theorize about it all you want, but we won't know unless we could lay our hands on it. But I don't know. But yeah, that's great. Let me see. I would love to see. I know you're a busy guy. If you ever have time or just kind of bored, do that experiment with the temperature. That would be fascinating to see if you could actually capture the same result and have some kind of explanation for it. I'd love to hear your idea of that. But then I hope I'm not hogging up the time. I mean, I have other questions, but I can wait if other people have things they want to say. I feel like go ahead.
We only have a handful of people on the call, so yeah, go ahead and ask your questions.
So here's another question. There have been, and I'm not I don't want to sound like a nut here or whatever, but I tend to think outside the box. I don't accept just whatever, a mainstream science says about the world. And there's a lot of buzz going around on the internet right now. All these people that's gaining momentum is this whole idea of a flat Earth. I don't know that the Earth is flat. I'm not trying to say yes, it's flat. No, it's not ball. What I'm saying is I'm at this point now, especially listening to research like yours. I'm open-minded to what the possibilities could be. Like, what could it, if we can't see the sun, unless it comes through our atmosphere? It just seems to me that the whole thing is on its head. And so here's some questions. Look, just some questions I have. How could we see so many miles in every direction? Like, if I drive to my mom's house in Elk Grove, which I will later this afternoon, I'm only supposed to be able to see, because the science says, and it's not even like good science, it says 8 inches per mile is like the rate of this of curve, which is a grade, not a curve. The actual curve would have to be 8 inches per mile squared if it was a parabolic curve that wrapped around 25,000 miles. I didn't do the math, but a lot of people have, engineers and whatnot. And so here's my question. How is it then that when I'm only supposed to be able to see like 30, 40 miles before the curve starts covering up what's on the other side of it, I can see 30 miles to the mountains, and none of the mountains are covered at all. They should be under 300, 400 feet of curve. But I can clearly see it with my eye. Now, there's a lot of theory about mirage and extreme mirage or special mirage or whatever, but, I'm seeing this in every direction no matter where I'm at, 360 degrees. There's just not mirage everywhere that perfectly fits. Do you understand what I'm saying? I can see way further than I'm supposed to. We can see across Lake Michigan 98 miles to Chicago, and it should be under 1,500 feet of curve, and it's not a mirage. They can put a camera on it for a whole 24-hour cycle, and you see the weather. Anyway, I'm rambling on and on and on. Is it possible then, not necessarily that the world is flat, but it's actually, there's other people who've said maybe it's 10 times bigger than they're actually admitting or saying that it is, and that could actually answer for the fact that you can see almost forever because there's almost no curve at all. Have you any thoughts on this at all?
Well, this is a big deal when you're building microwave relay systems for long-distance telephone. What goes on when you're trying to go from one end to the other, and it's a lot more complicated than it just seems by simple ruler-type geometry. Considering the Earth to be flat is lunacy because obviously, all the engineering that's gone into satellite communications and the pictures of the Earth from various altitudes and all that. We can forget about the Earth being flat. That's for people that believe that the spaceships were invented by aliens and not us.
Okay.
So there's something I'm trying to find that I got a Bell System reference book here, but you can never find anything when you want it, particularly in a book that's about 700 pages long.
Yeah.
There's a couple of things here. One of the things you deal with is these situations called Fresnel zones that split the microwave beam path up so it starts taking other paths. And then there's also a type of communications that's pretty much not existent anymore because the satellites do so much of a better job. It's called troposcatter, where you could have two antennas that see each other at a distance of several hundred miles apart by using
radar goes that far too.
Yeah, you can build radars to do that too. There was a massive system out at an island called Quadriling, where a lot of development, Bell Telephone Laboratories built a massive over-the-horizon radar system for the Air Force. I don't know that much about it. That's kind of outside of my area. I'm more into the communications aspect of things. But
right.
But what you can see and what you can hear and what you can experience via wave propagation, with respect to distances on the surface of the Earth and the curvature, it can get really complicated, particularly when the ionosphere is involved. Then you can get incredibly complex propagations. That's the basis for this thing that I call the Earth stereo, where you use the propagating medium between the ionosphere and the surface of the Earth has a concert hall where the Earth is the floor and the ionosphere is the ceiling, and you're inside this spherical concert hall, and then you have some radio station overseas, like in China, let's say, emitting a signal, and then you have a specially designed receiver called a dual diversity receiver with phase coherence, and then you play that station in stereo through a stereo sound system with the special receiver. Then you're sitting inside the concert hall of the Earth, and it's a very dynamic propagation situation. And that way, then you can actually feel what's going on at that point, because of the way the stereo operates. Is all these different factors then become directly experienceable in the way they influence the sound.
Yeah, that just went way over my head, but maybe if I listen to it again. Yeah, it's definitely an interesting idea, though. It seems to me that if there is some sort of, like you said, Frenzel effect going on to bend microwaves, I'm aware that, like, Tesla, believe that you could adjust radio frequencies or the frequencies of energy to direct it wherever you want it to go. So I guess they wouldn't have to travel in a straight line if you knew what you were doing. We have radar that it'll read all the way to Russia if they've launched their missiles. It's like 3,000 miles away. So then they are actually directing that radar around the parabolic curve of the Earth to be able to detect that. That's what you're saying?
Well, most of that's going to be what's called troposcatter. So there's various layers of the atmosphere.
Bounce back.
One of the layers of the atmosphere, the one below the ionosphere, is called the troposphere.
Right.
I forget exactly how high up it is. So I have all the references here, but, the time it takes me to dig it up, let's just say, it's below the ionosphere, so that would make it, somewhere like maybe as an order of magnitude 10 miles up. And the transition of going from a more dense atmosphere to a less dense atmosphere causes the waves to get trapped into the troposphere.
Oh, wow.
And with the proper angular positioning of the transmitting, or I should say, the sending end and receiving end antennas, it's bidirectional, of course, but, because it's two-way telephone conversation, but at any rate,
right.
It's symmetrical, so what goes on one way usually goes on the other way, but when you start to get into these type of situations, the laws of reciprocity sometimes fall apart, and it'll take a different path going one way than it will the other way, but in general, you can view them as the same. So troposcatter was used for long-distance communications extensively by the military, particularly the Air Force, and it was the means in which long-distance telephone was brought into Alaska with the efforts of Radio Corporation of America to design that tropo system. I forget the names on this. Jerry Vassilatos wrote a book called Secrets of Cold War Technology that gives a kind of popular representation of all these different types of transmissions. So that book might have some references in this of what the names were. I think the thing was called White Alice or something like that. So the over-horizon radar would have to work basically on the same principle.
Wow,
requires
okay.
inordinate quantities of power.
Yeah, well, it's just a dish like the size of a football field.
The attenuation is very high, where normally your line-of-sight radio links use somewhere around 1 watt. Those are the things you see, on the hilltops around towns and what have you with the microwave dishes. Those are about 1 watt per transmitter on the dish. But the tropo systems operate around 5 or 10 kilowatts. So you can dangle your hot dogs in front of the antenna and they'll be done quite quickly.
Yeah, I've heard about don't stand on live antennas. You don't want to do that.
Yeah, so at any rate, those antennas are kind of kept away from people. And then the other complication with troposcatter is, like the name implies, it's scatter. The signal at the receiving end is all twisted up, like this thing I was talking about with the Earth stereo. So the medium in between has basically boiled the sounds. They're in a turmoil. The signals are in a turmoil when they get to the other end, and you usually have to use a diversity receiver pair so that you can take the two twisted signals and put them through a comparator and then get a reconstructed output that's still intelligible. But now with satellites, troposcatter is no longer necessary, and most likely any type of long-ranging radar now is not really going to be point-to-point on the surface of the Earth. All this stuff is going to be satellite-orientated. There's basically a whole other world of satellites circulating the Earth right now. What's going on and how they're getting back and forth and all that kind of stuff is way beyond what anybody can imagine. You can almost say that there's a whole other world up there right now looking down on us. So Earth-based stuff is it's like the Navy's going out to sea and it'll probably crawl into the hollow Earth. The Air Force is moving out of the Earth and in the outer space and looking back. So, and then we're left in between.
Yeah, that's interesting. I know it enters the realm of conspiracy theory and stuff. The whole idea of satellites, though, is definitely like a whole other fascinating conversation. There's some issues with that. Typically, that we're told we can see a satellite running across the sky at night when you see what looks like a star drifting across the sky, but the size of what the satellites are, I'm having a hard time believing I'm seeing a reflection off one that many miles away. It's just it's hard for me to swallow. But beyond what I can see with my naked eye, there's some other questions about satellites, how they even survive the temperature up there, and people in orbit. I know there's a whole world of people that believe that we've never even been into space, and I don't know that I'm there. Again, I'm just kind of open-minded. I don't really necessarily trust anything that I've been told anymore. I just don't. And it's more fun to try and figure it out on your own. It doesn't really matter to me. It's not like I'm gonna die if I don't believe in outer space, or I'm gonna be free if I do. I don't know how important it is. I'm not a teacher or anything, but there's some really good questions about that. Like the satellites are supposed to be orbiting in the thermosphere, which is supposed to be too hot to exist in. That burns everything up. And then the scientists say on the flip side of that, well, no, there's no heat exchange because there's so few particles of any kind of gases or matter that it doesn't conduct to the satellites. But then if we have a person in orbit in that same thermosphere in the ISS, International Space Station, then how, if it does conduct, the thing would melt because it's made of aluminum and Kevlar. If it doesn't conduct, how does the space station deal with getting rid of heat that builds up inside the station from all the electronics running, the people breathing and living and moving? There's no way to conduct that heat out of the space station. There's nothing to conduct it to.
Well, that's not true. You can have any kind of refrigeration system and use some kind of liquid to carry the heat and deliver it wherever you want. And then, these satellites are, they're out there somewhere around 24,000 miles in outer space. There's not much of an atmosphere left out there. What's going to happen is one side is going to get the direct radiation bombardment of the sun.
Right.
The other side is going to be ice cold because there's basically no source of heat.
Right.
Whatever heat exists just radiates away into the blackness. So the big complication is the thermal gradient. Is one side, is exposed to all this radiation, but then you have to remember that aluminum, in all probability, will reflect a lot of that and won't absorb it. And they'll know exactly what it is that's out there. So at any rate, all these things, unless you're there and you design this stuff, there's no knowledge available on that. And
right.
People can run and stick their heads down the bowl and convince themselves that we've never been in outer space and all this. And there's so much drivel running around, that the proof that the whole thing is, we never went to the moon, all this and all that, I don't know what's wrong with people other than, they seem to be endemically screwed up in the head, as evident. All you got to do is walk outside.
Right. Yeah, there's no doubt. But there's a lot of people.
My proof that the moon thing was real is I defy anybody in any of those photographs that were taken during that whole moon episode to see any stars. Now, if they remember to put the stars in Star Trek, but they didn't remember to put the stars in the Hollywood set for the moonshot, come on. Why aren't there any stars? Why can't you see the stars? Maybe what those early astronauts said were right. There are no stars when you get out there.
Right. Right. Yeah, I agree. There may not be visible stars out there. One question from the moon photographs, and obviously there's a whole ton of stuff. I'm not even going to bring up all that. But one question
we're kind of getting, we're getting off into the, the Art Bell show now. So.
Okay. All right. No problem.
Getting back into the world of engineering.
Okay. Well, I appreciate your patience there. You did answer a whole ton of things I had to think about, and I appreciate it. Again, I'm just an open mind. I like to try and understand the stuff for myself rather than just take the word of, somebody with a big fat degree. So I appreciate you taking your time to explain that stuff to me the best you could, and that's all I got, man. Thank you.
Okay, you're welcome.
Well, hey, if anybody has any questions, just hit 5 and the star sign, and that'll put up a little mark there. Okay. Yeah, go ahead, Jeff.
Hey, Eric. Can you still hear me now?
Yeah, go ahead, Jeff.
Okay. Yeah, it said hand lowered. Okay. So Eric, last conference we talked about the dielectric capacity of water when you and Al were sitting there at the final part of the conference. John jokingly gave his analysis of why he got into his stuff that he did by throwing a capacitor up in the air and the 93 volts per meter, electrostatic charge, of the gradient. There's a guy with a fan that's coming to the thing with that looks like a squirrel cage fan, 1 mile per hour fan. Is there any way to kind of like tap into like a Van de Graaff type belt generator with the dielectric constant of water and doing some other maneuvers to basically use that charge moving to charge some of these dielectric batteries that we were talking about like last year?
Well, there were dripping water electrostatic generators.
Mm-hmm.
And then the Tesla electrostatic generator is a hydrodynamic type of situation, but it uses compressed air instead of water.
Okay, so the moisture content is really the dielectric in there.
Well, it used air instead of water, but in the water dripping one, then the dielectric constant of water comes into effect because then the electrostatic flux is captured into the higher dielectric constant. The water has 80 times the ability to store dielectric lines of force-free space, so it's a pretty good concentration, which also means there's a very heavy refraction involved with water, too, like when you're looking into a pond or something, because dielectric constant at 80 is way beyond, like, normal liquids. And, insulating fluids like transformer oil and stuff like that, where the dielectric constant's only about 4 or 5.
Right.
So there's possibilities, but, electrostatic machines are not necessarily my expertise.
Okay. Well, that was kind of like I had some stuff that I was going to work with Aaron on. I was just curious about that from the aspect of moving energy around with some of the liquid storage in a different charging application.
Okay.
Okay, thanks.
Okay. Hey, Eric, that dripping one you're talking about, is that the Lord Kelvin's thunderstorm?
I'm not certain, but I know, that I ran across, reading all these old books, all kinds of different ways to produce, dielectric induction with spinning things and moving things. And the Tesla forced air electrostatic generator is probably the most effective of all of them. That was we've always heard about the Tesla so-called death ray, even though anyone that's had anything to say about it has only been able to emit pure drivel. But there's a person by the name of Leland Anderson that put out several publications which were in effect reprints of Tesla's own statements on the matter, and he produced one of these booklets based on the Teleforce concepts as described by Tesla. One was his so-called earthquake machine for sending mechanical waves through the earth. The application in Tesla's mind was for finding ore bodies and things like that. He was very descriptive about it. He uses all kinds of very fundamental arithmetic relationships. It makes it very easy to understand quantitatively what his ideas were. And then the other one is the particle beam, and he describes this electrostatic generator in detail that has considerable output. And then it also shows that that Tesla utilized the Crookes theory of material expulsion in his cathode ray tubes, which preceded the Thomson electron and positive corpuscle theory, and used the Crookes repulsion concept to create this beam. The repulsed material was mercury vapor, and that was how this thing operated. So Leland Anderson's Teleforce book would be, you can see this electrostatic generator, Tesla's drawings of it, and his description how it works, and what he thinks about that particular type of electrostatic generation. And he seemed quite perplexed in some of the other papers that went along with this. I don't know if they're in that book or they were something I had separately. But he seemed to think that the law of conservation of energy was not holding up well in electrostatic generators in general, which is something that I proposed some time back, is anytime you have an inductance or capacitance that's varying with respect to time, it produces a parametric EMF or displacement current, and that might not go along with the law of conservation of energy. So that's about all I really know about the electrostatic stuff in detail.
Thanks, Eric.
Okay.
Thanks, Jeff. Let's see, if your phone number ends in the numbers 753, go ahead and ask your question.
Hi, this is Robert from California. Hello?
Yeah, go ahead, Robert.
For me?
Yes, go ahead.
I had a question, but when you talked about the water, I kind of thought of another question relating to water. Are you familiar with the fourth phase of water by Dr. Pollack, where the water exists in a H3O2 form rather than H2O form, and it's like a semi-liquid crystalline structure to it, and it creates charges just by being near a hydrophilic surface, where it can store energy within the negative and positive charges that get automatically separated. That was one thing that I wanted to bring up. And my other question was, years ago I remember reading Eric's explanation of how electricity flows within the wire, rather than having the charges move in there by themselves. They were being dragged by the fields outside of the wire, outside of the metal conductor. Is there any new explanations or anything new in that area? Those are my couple of questions that I have.
So that's your two questions?
Yeah.
Okay. Yeah, I can't. I'm no expert on the chemistry of water, and I don't really study that, so I can't really comment on what's being said on that deal, even though I know there's all kinds of possibilities, numerous possibilities of how water can be polarized, and it's made itself famous in being able to be polarized in so many different ways. What you're talking about as far as the conduction currents and all that is, in general, electrical theory. The traveling wave drags along the wire, and that's what heats it up. It's not conduction inside the wire. What goes on inside the metal seems to interfere more with the process than contribute to it. So this is something I'm going to try to get into in my presentation. For every conductor, there's a certain critical frequency where you're making the transition from electricity inside the conductor and electricity outside the conductor. And the more the frequencies want to be inside the conductor, the lower the frequency, the more it wants to be inside the conductor and not repelled from it. The velocity of light theory of transmission fails until finally when you get down the direct current, according to electromagnetic theory, you can't have any transmission at all, but obviously there is transmission. So the interaction between the electric field and the metallic substance is a very deep and mysterious subject. I wrote a whole notebook on this that is one of the chapters in my transmission book. It was the original J.J. Thomson description of how the process of resistance and skin effect comes about, but it's highly abstract. I managed to simplify it as much as possible, but Thomson's visions on these were not totally clear, so he didn't make it easy to understand in his books, amongst with other complications that made it next to impossible to understand. But I think I reduced it to a common language level as much as humanly possible. It's only algebraic and geometric relations. So I think there hasn't been any money or what have you to print that book up, but I think those notebooks are on the internet now in their raw form.
Is that the recent books, Eric? The notebooks 1 through 5?
Yeah, those are the notebooks 1 through, I'm talking about notebook 4.
Okay. Yeah, if anybody goes to, eventually those will be on the Extraluminal site, but right now they're on if you go to powerofether.com, that's ether spelled with an A, A-E-T-H-E-R, powerofether.com, and scroll down, you'll find 2 sets of notebooks, 1 through 3, and then 4 and 5. And those are just for expediency. We scanned those in and made those available in their raw scans. Eventually they'll be transcribed, but that's where you can find those notebooks.
Yeah, and then notebook 5, that's kind of a continuation with this whole interactive thing, dealing with the Steinmetz force equations. Steinmetz finally kicked the table of the money changers over when it came to physics in their futile and worthless attempts to explain the forces on conductors. So Steinmetz did it based on the law of conservation of energy and some very simple algebraic propositions. So what's interesting is when you have electrical transmission down the transmission line, such as 2 wires on a power line, when you send a so-called current down the line, which is represented by the magnetic field, the wires are physically pushed apart, the force pushing on the wires being proportional to the square of the current. So during a short circuit condition, this force can get rather extreme and rip the wires out of the insulators and send them flying out onto the cross arms. This is something you have to worry about when you're electrical engineers. This stuff can all start flying around all of a sudden on you. Conversely, and this is what's never talked about, and Steinmetz didn't talk about it either, but he does provide the necessary relationships to shift coordinate systems into the dielectric coordinate system, is if you send an electrostatic potential down the line that pulls the wires together. So if you have a situation where you have a very high voltage transmission line, but the current demand at the end of the line is very small, then the wires are pulled together. But if you have a low voltage transmission line where the current's high and the potential is small, the wires are pushed apart, but there's a certain ratio of voltage to current where the force of current and magnetism pushing the wires apart and the force of potential and dielectricity pulling the wires together is neutralized, and that is what's commonly called the characteristic impedance of the circuit, the impedance being defined as the ratio of the potential supplied to the line to the current that's flowing down the line. And at that point, there appears to be no material existence of electricity. The forces are neutralized, and then you have to ask yourself where the electricity went. So this is an interesting way to look at electrical transmission that's never been done before, is to deal with it on the level of forces. And then at that point in which the two forces are neutralized, the ether has congealed into this entity that I call the Planck, which is the product of the magnetic induction and dielectric induction. And then the electricity can be viewed as ether particles bound by the transmission system, and the lengths of force are neutralized in that there's no forces left over, there's no stored magnetic energy, there's no stored dielectric energy in the line. It's purely a Planck process of propagation from one end to the other. So this is similar to the situation where in transmitting DC you can't have a velocity. So there's all kinds of fascinating details going on with transmission once you start to get into the basic relationships and analyze it. It really is its own world, and it did occupy the mind of some of the greatest electrical scientists in history for over 100 years. But, of course, now all that knowledge is considered obsolete and worthless. But at any rate, it's still fascinating.
Well, thank you for that explanation. Have you worked with any nano-coated wires? The nano-coating acting as a sort of an insulator, and how that affects the performance of the wires? Because since the charge...
No, I've never really encountered any of that kind of material, so I don't have any knowledge on what's going on with that.
Okay. Well, thank you.
Okay, welcome.
Okay, thanks for your question. Let's see. Looks like you might have a Skype number. You have your hand raised. You hit 5-star. Go ahead and ask your question. Okay, let's see. I'm going to hit a button here, and if you hear that your hand is lowered, go ahead and ask your question. You should have just heard that. Question. Okay. Let's see. You just raised your hand about 5 seconds ago. Go ahead and introduce yourself. And hello.
Can you hear me now?
Yeah. Okay. Yeah. Go ahead.
Oh, okay. I'm surprised. Hi, Eric. I didn't think that I was going to get on because I thought you had a long queue. I don't think that I should ask this question because it was in tandem with the previous question that was concerning the light coming from what apparently is the sun, which is still unexplainable. But if I could ask the question, I'd like to.
Yeah, go ahead.
Go for it.
Okay. Well, and this happened out of the same sort of research that the other gentleman was doing within the flat Earth environment. But what this is undisclosed information, which should be coming out once the computer graphics are created so the model is represented in a video documentary on it. What it may be is an anomaly regarding light and its actual form, which is, of course, not taught to us correctly. And this form, I'll just make it a very simple analogy, I guess. If the light is concentrating at the point that we call the sun in a form that is twisting and then compounding on itself and then coming towards us, that it's inverting and upside down or reversed, that when it is spreading and covering the Earth's surface, it's really not coming down in straight lines. It's sort of like the model of the perhaps electromagnetic field that describes what light actually then would be. That Yeah, I could go on and on with that description, but my question is it possible that would be an explanation for what's happening when we're speaking of what the sun is?
Well, I mean, anything's possible, but how do you find out what's actual? So whatever propagation there is not really understandable to us, not with the present condition of things. So I think J.J. Thomson and his contemporaries got about as close as anyone was going to get, and then after 1900, everything just completely fell apart. This is kind of what's expressed in E.T. Whitaker's book, The History and Theories of the Ether and Electricity. Is what you find is the science of optics, the science of electricity, the science of physics, and the science of biology, and all these different things where nothing really fit together. The science of optics could never be resolved with the science of physics and the science of electricity. And by 1900, everybody had just pretty much given up. It had become so complicated, the mathematics was so thick that it completely departed from reality, and then it just kind of consumed itself in its Babylonian extent, and that was the end of that. And then we have what left is the modernists and the relativists and the quantums and all that, which is just pure goofiness. So I would go back to J.J. Thomson and all those people and start finding articles they wrote and discussions between them and, their certain contemporaries, and go back to the old journals. If you can find that stuff anymore, it's all been pulled off the library shelves. So it's a very complicated subject, and it's way beyond me.
What I'd like to do, if you don't mind, just because there are probably several people out there wanting to field questions, and I don't want to overdo it, is if you would accept a link or I'll send you a link, and it'll show you a page with diagrams of what I was trying to describe. It would be it would be easier to understand.
Yeah, but the thing is, I don't allow computers or any of that stuff in my life to the best of my ability, and when it does get into my life, like recently with this email sickness, it creates nothing but problems in my life, so I don't want anything to do with the digital Babylon. So what you'll have to do is you'll have to send me a letter to my Lone Pine address and put that in it, and then when I'm in the bushes there, I can examine it and see if there's anything of interest, and I always write everybody back, so I'll tell you what I think about it.
Okay. I wanted to visit with you at the conference, but I think that they're all sold out, so I'll do it this way then.
Okay.
Yeah. Thank you very much.
And there are still seats at the conference. You can register at EnergyScienceConference.com. And the address Eric is talking about is Eric Dollard, General Delivery, Lone Pine, California. I believe the zip code is 93545. But you can double-check the address on ericpdollard.com. If you look in the right column and scroll down, there's one address for donations, and then there's another address in Lone Pine, which you can send any kind of letters or whatever you want to directly to Eric.
That'd be terrific. I was unaware that there were still seats available. Okay.
Yeah. Okay. Well, thanks for your questions. Let's see. I'll go ahead and go on to somebody else here. Okay. Let's see. If your number is ending in 1093, go ahead and introduce yourself and ask your question.
Hi, Aaron. Hi, Mr. Dollard. Can you hear me?
Yeah.
All right. So I was reading the book of Mr. Jerry Vasularis, and when he mentioned that Tesla discovered the radiant energy is auto-intensified when finding or meeting segmented objects. Can you please expand on that? And if does the segmented object refer to the EV Gray motor when the tube, the the grid on the tube. Is that what Mr. Jerry Vassalatos is referring to? And if you can expand a little more on that, that would be helpful. Thank you very much.
Okay. Yeah, I kind of didn't get the middle part of it. Radiant matter is really the proper term for the thing. Radiant energy is kind of another person's interpretation, but the subject is called radiant matter, and it's a concept that was developed out of the experiments of Sir William Crookes, who was a pioneer in the development of the vacuum tube. In fact, actually, he can be credited with inventing the first real vacuum tube. So Tesla did a lot of work in radiant matter that Jerry Vassalatos talks about in there, that he could actually feel the impacts of the projected particles on his body, and that he could collect them and what have you, but I'm not certain what your specific question is on that. Maybe Aaron heard it better than I did.
I will reset again. I was just thinking, I might be wrong, I think, because when he mentioned by segmented object, the more the radiant matter or energy auto intensify when finding segmented object. That's what he wrote in the book.
So what are you saying? Cemented objects, like in cement?
No, segmentation. The key is segmentation.
No, that's the word I'm not getting. I don't know what that word is. I can't understand it.
Yeah,
here.
I got it. Yeah, it's segmented. You know, let's say there's glass.
Segmented.
I'm sorry about not. Yeah, that's Aaron said it right.
Yeah, segmented. So when the so-called radiant emission or whatever hits like a grid, which is like a mesh or something, does it fragment it out?
Well, that I'm not certain about. I have not seen Tesla write anything specifically about that. It's quite possible. Jerry Vassalatos found some sources on Tesla material that were not generally available and now are completely gone. So that's always been a question of mine, is where did Jerry Vassalatos get a lot of the material that he used in that book? He did get a couple of things completely backwards, but completely backwards is better than kind of backwards, because then all you got to do is turn it around.
Yeah.
And he makes a lot of his own interpretations on things, so it's kind of the value of Jerry Vassalatos' book is it introduces to the popular reading, whatever you want to call it, the uninitiated in this, the overall view and concept of what was going on and all this stuff. But quite often, he'll get the name of one tube swapped with another, or so it creates a big difficulty. But nevertheless, he does expose the subject, and then the best thing to do at that point is Tesla gave numerous lectures that made him world famous, demonstrating these phenomena, and they have been collected into readily available books. The first one was produced behind the Iron Curtain in 1956 and called Notes, Lectures, and Patents. I think that's probably widely available now. And then there was a number of books that I made reference to early on that I can't remember the names of that discussed the radiant matter science that was going on at the time. But the only thing I could suggest is to go back to the original writings and then read that and then get right it out of Tesla's mouth. And after you've been kind of introduced to the subject by Jerry Vassalatos, then it will be easier to see what Tesla's getting at. And you might find the answer to your questions in there. But I've read all of that extensively and have memorized pretty much anything of significance. So that's one thing I don't particularly remember, is using some kind of segmented structure to interfere or act with the radiant particles. And unfortunately, Jerry Vassalatos is very weak on giving references to where to find stuff. So I'm kind of at a loss on that one, but there might be something in the available writings of Tesla.
Yes. One other question concerning the EV Gray motor. When
that something is completely out of my area. I have nothing to say on that.
All right. Understood.
Okay.
Thank you very much, Mr.
Okay.
Ballard, and have a good day.
Okay. And I can comment. I don't know if you've seen Peter Lindemann's book, Free Energy Secrets of Cold Electricity. That's where he used. Okay, so yeah, he used Basilato's book as like a Rosetta Stone to kind of put that idea together on how that works. That's probably the only thing out there that I know of specific to that. So yeah, if you've already read that, then you pretty much have what's available.
All right, thank you very much, Aaron.
Sure. Okay, let's see if anybody has any questions. We're going to have to wrap this up here in about 10 minutes. Go ahead and hit 5*, and that'll give me a little symbol that you want to ask a question. Yeah, just hit 5* if you have a question, and I can unmute you if you're muted. Okay. Well, if nobody else has any questions then, and it doesn't look like it, there are, we can go ahead and wrap it up. Do you have any final comments, Eric?
No, I figured there'd be more questions in this, but I guess it ran out. I was ready to go for another hour or so.
Okay, let's see. Okay, if your phone number ends in 753, go ahead and state your name and ask your question.
Yeah, if you guys are still looking for questions, what are your thoughts on plasma, cold plasma, as it relates to electricity and magnetism and gravity, and any thoughts on plasmatic energy?
Yeah, that's again something I'm not really familiar with. The only cold plasma that I know of is involved in earthquake research. The intense electrical fields that are developed prior to an earthquake, which can reach current levels of many millions of amps. Because apparently what happens in a certain pressure situation, the rocks will create an electron plasma that seems to have properties different from regular current flows, either conduction or displacement current. I've talked personally with the person that's doing research in this area, but in general, that's not something I'm particularly knowledgeable on.
Okay, thank you.
Okay. Well, if
a quick suggestion, Aaron. Can you do these meetings maybe in Zoom or something that would be easier to share text or visual information? I know Mr. Dollard may not participate that way, but just with the phone. But if you get the information in visual or text, you can relay it to him easier. Just an idea.
Yeah, I've done some like GoToMeetings or GoToWebinars in the past. They actually did work out pretty good, but most of the good ones cost money every month, and we'll only use it maybe once a month. Mm-hmm. But yeah, no, I'm open to it. If we get some more things regular scheduled, then that is something that can work.
Okay, great.
So yeah, absolutely. Okay. Well, we'll go ahead and wrap it up. Again, Eric will be speaking at the conference July 8, 9, and 10. You can find the info at EnergyScienceConference.com. And if you're able to support Eric's work by giving a donation through PayPal or by check or money order, you can find out how to donate through ericpdollard.com. P stands for Paul. That's his middle name, ericpdollard.com. And in the right column, you can find a PayPal donate button or the address where you can send donations. And if you want to send Eric a letter through the mail, there's an address in Lone Pine, and Eric usually will write a handwritten letter back to you. Any final comments or anything, Eric, or requests or anything?
No, I mean, that seems like it's pretty well wrapped up. Other than as far as the donations go, I should point out that we really need a real big one right now because we're held up on getting our terminal facility together. We either have to lease from a cellular telephone syndicate or we have to build the terminal building, which is a pretty good sized chunk of money. We're looking at about $30,000 or $40,000. So if either for a long-term lease or to put our own building together, and then each of those two things has a geophysical difference, we have a complication in that we can't really get all the facilities in one spot for one reason or another, a lot of them being geological, others being severe interference from the power company. So that's kind of our hurdle right now. Everything has been changed as far as priorities here because of the imminent California earthquake. Getting reception and recording devices together for this priority has superseded everything else. So a lot of stuff has been scaled back, and certain projects have been found to be non-feasible because of there's no real funding for this. We've gone through every effort to find grants and what have you, and the analysis is between a wide spectrum of people, including the people presently involved and receiving grants for earthquake research, is that advanced seismic warning is a completely taboo subject, and there is not one dime available for it. So this is what we're up against right now, trying to move forward with this. So it's going to have to be something, believe us, we call Jesus money, where the spaceship just comes over and dumps out a bale of $100 bills, because this money's obviously not going to come from any other source.
Now, this terminal building, is that what's going right by the entrance to the mine, the seismic mine, or is
yeah, we have two terminals right now. We have a very sophisticated seismic monitoring facility in the detection and the mine that harbors the equipment. But we have to put a building at the entrance of the mine to put all the racks of equipment that amplify and process the signals. That will give us the geophysical equipment that we need at our primary location. And then the other location right now is the best one for the telluric electric wave reception. This is something associated with a microwave complex and what have you. And we have to come up with a long-term lease to be able to get into the building and install the necessary recording equipment. I expect we will have the reception antenna and the transmission line to the radio facility complete by the end of June, but I don't know the way things are behaving. People seem to be, there's some kind of massive wig out going on right now, and it's making things very difficult for me. But the objective is to get the terminal racks in this building, connect it to the telluric electric wave reception antenna, and then record this stuff. So we'll need to find some kind of recording device that can record a high-fidelity stereo signal for periods of 30 days with the date code, but then I'm realizing that that nothing is made anymore that does anything. It has to be some kind of contrivance of computers or whatever, so I don't have a clue what we're going to use, because this isn't the real world anymore, so there's no real-world objects out there. So I'm probably trying to find something that's just about as easy to find as my 1980 Toyota Corolla. But at any rate, that's what we're trying to get done. We estimate we need $20,000 to secure everything at that facility, and then the rough cost estimate for the terminal facility for the physical, mechanical seismographs is about $35,000, which will also then contain the terminal equipment for the telluric receiving facility, which is going to be much more advanced at this particular location, but we don't have time now to be fooling around with experiments and studies and all that. We got to get things together that pick up these signals right now. So that's what we're up against. And then basically the cost of keeping this building going just soak up all the funds, and there's really no money left to do anything other than what I can pay for out of my Social Security. So another and possibly the most imperative thing that is necessary as soon as possible is we need to get everything paid off here so that it's not a massive parasite on our finances, so that we can try to get ahead here somehow with this stuff. And then it's come to my attention that there are various experienced linemen in this part of the world, Nevada, that have offered their help, and that would be particularly important for the western end, where there's a lot of rigging and things that need to go on here that are very difficult for me to deal with by myself with what little help I have. So we're quite open to that. I can't.
I'll put out a call for that.
I can't put any. I can't really pay for a lot of food or, lodging, or that's the complication. And no one wants to rat it out with me in my car in the desert. That's kind of too brutal for most people. They might die in the process. So, at any rate, so we're up against a really solid brick wall, and we're going to have a sit down on the thing between ourselves and figure out how to regroup, because there's just simply nothing available for this kind of work at all. It's and the tragedy is we have almost all the equipment and parts, and we've all been set up with miles of wire and terminal equipment to send the signals to different locations that no one would expect to even see on the Earth again. So material-wise, we're doing fantastic, but we can't get through this physical plant hurdle and some basic funding to try to really go forward with this and produce what I used to have in the past at Landers that all got destroyed, that has been estimated to be $1.5 million to replace. So that's what I'm up against, and it appears to be hopeless. So maybe there's somebody that will receive this signal that knows some very wealthy person or somebody of influence that can get us the proper military grant or something. It can't be academia. It's going to have to be something independent of academia. See if we can pull this off, and it's quite possible this will be the year of the big California earthquake. So lollygagging and all that kind of stuff has to end.
Yeah. Well, Eric,
I've gone as far as I can with it.
What I'm going to do is I'll put together some kind of form that anybody who might be able to be a volunteer, who's qualified, some lineman background or whatever, I'll just post a link somewhere and have somebody fill out a form, and then I can just print those out and mail them to you or something, and you can kind of look over those to, kind of see who.
Then, when it's time, when the weather cools off again, and it's time to get really intensive on this project as far as the test site antenna goes, that'll be about the time, like probably starting September or October.
Okay. Hey, let's see. We have one quick question from Jeff. If you can make it really, really brief, we got to wrap this up. Go ahead.
Eric, is your summation of a big one from some of the ELF measurements from Steve, or some other basic measurements in the mine?
This is something that's very well understood in the conventional seismic realm. So. By Steve, you mean Steve McGreevy, right?
Right, correct, right.
Yeah, well, when I'm in Lone Pine, then because it's Steve McGreevy's signaling equipment, I have direct access to this stuff normally, but sometimes, the place I stay gets compromised, and I'm going through that right now, and I have to move to another location.
Well,
so I can't get the signals. The stuff in the mine is not even connected, but but this basic Earth signal device, if you can get the thing out into an area that's free of interference, which pretty much means, you're going to have to remote it or you're going to have to live outdoors.
Like an RV? Could an RV house it?
Even that in its simplest form will give at least a 12-hour warning. So I listen to this thing all night, every night. There's quite a variety of signals. So anyone that lives in a peaceful location in the Southern California area that's not inundated by power line interference can just simply have one of these devices running all the time, and it'll let you know beforehand. But as far as the overall timing of the earthquake and the magnitude and that kind of stuff is the California earthquake cycle, so to speak, is based on a 20-year repetition, roughly, which tends to correspond with the solar cycle. So what it does is there's alternate earthquakes when the forces, are being distributed from the lockup to the point in which it breaks free, and then there's the points that aren't locked up where earthquakes occur all the time. The overall dynamic of this is such that one earthquake will occur in Northern California and another earthquake in the next cycle will occur in Southern California, and then it reverses back and forth. That seems to have been consistent. So now the last major earthquake of the San Andreas fault system was the Loma Prieta, which occurred in Northern California. So that sets the clock for the next California earthquake, which will be in Southern California. So that time interval is already here. It's arrived. The particular position in the solar cycle right now is also favorable to it because this is part of the solar cycle that produces the most magnetic activity on Earth, which causes the Earth to physically change form and wobble and vibrate. So the excitation is there to cause the earthquake to break free. And then beginning with that massive Indonesia earthquake that produced the famous tidal wave, all earthquakes since then, as you can ask anybody in Japan and they can tell you, are 10 decibels stronger than they used to be. So an 8 is now a 9, 7 is now an 8.
Oh, wow.
So the Southern California thing could really change things.
Okay, Eric. Hey, that's what I wanted to know. Yeah. Aaron, could you forward some of the data on the costs and then the audio for me for a link, and I'll try and forward it to someone who might be able to help the guy that I sent you the audios for?
You're talking about the audio for this call?
Yeah, the audio and the numbers at the last couple minutes that Eric was giving out for the what he needed.
Yeah, I'm going to be here in a couple days. This will be up on YouTube, and I'll be putting a link out on the list, and I'll post it on the website and everything. Yeah.
Hey, Eric, I really appreciate it. Thanks for the warning.
Okay, you're welcome.
Okay, well, we'll go ahead and wrap it up. Thanks a lot, everybody, for being on the call. Thank you, Eric. If just check out ericpdollar.com, and you can go ahead and write him a letter to his Lone address. And, I'll announce when we can do another one of these calls. So thanks a lot, everybody. Thanks, Eric.
Okay, bye.
Happy Easter.
Happy Easter. Thanks, everybody.